Welcome back, everybody. In this video, we're going to take a look at the beginning ideas of working with fractions. So let's get started. So it says here, Introduction to Fractions and Mixed Numbers. So we'll be looking at both aspects there. The big idea is that a fraction is one of the two ways that we use to represent quantities that are part of a whole amount. We've seen working with whole numbers and positive and negative numbers, how to work with quantities like that. But so far, we don't have ways of answering questions like if you have, let's say, 4 apples and you need to split among 5 people. How much apple does each person get? There's no way to answer this question using just the whole numbers. And so that's where fractions or decimals come in. In this video, we're going to work on fractions, which is one of the ways, like I said, of representing parts of a whole quantity. So it takes 2 numbers to express a fraction, called the numerator and denominator. The denominator is on a fraction, it's the bottom number. It's the number that one whole is divided into, how many parts is divided into. The numerator is how many parts are indicated in the particular value that we're talking about. The bar in between the numbers is called the fraction bar. As an example, if you have the fraction 5/6, the 6 represents the number of parts in the whole, and that is the denominator. The 5 represents the number of parts in this particular value and is the numerator. So if you wanted to visualize that, we could draw one whole and divide it into 6 parts. And out of those 6 parts, we want to consider 5 of them. So let me shade 5/6 of this rectangle. And there the yellow bar represents 5/6 of the entire shape. Okay, just to practice a little bit with numerator and denominator, we want to identify the numerator and denominator for each fraction. So in the first case, the numerator is 11, and then the denominator is 2. And then for the second one, the numerator is 10y. The denominator is 17. In the last case, the numerator is 6x, and the denominator is a minus 2. Okay, for the most part, frequently we'll start out with just fractions where the numerator and denominator are just numbers and don't involve letters, but going forward, eventually we will get to that point where we have fractions whose numerators and denominators contain letters. Typically, people find fractions challenging, working with fractions challenging. There's a couple of reasons for that, and I wanted to go over that next. The reasons that working with fractions can be kind of challenging. For some people, it's really scary. And the point is there that knowing why these difficulties can arise can make it ultimately easier for you. Okay, so one of the kind of complicating issues with fractions is that it takes 2 numbers to represent one value instead of a single number. So as an example, part A here, suppose that Joe wrote 3 pages of his paper. Is that a lot? Okay, just giving you the 3 doesn't tell you whether that is a lot or not. If it's a 4-page paper and he's written 3 pages, then he is almost done. If it is a 20-page paper and he's written 3 pages, then he's barely started, right? So you need to know both numbers. 3 pages out of how many? Okay. Suppose that Kelly cut her cake into 12 pieces and ate some of them. Is that a lot? Okay, well, we would need to know probably how big the cake was in the first place. But out of the 12 pieces she cut the cake into, she ate some of them. We don't know whether that was 1 piece, 2 piece, or 11 pieces, right? So out of the whole, in addition to knowing how many pieces the whole cake here was cut into, we would want to know how many pieces we're talking about at any time. So we need to know 2 numbers. The number of parts one whole is divided into, and then also how many parts we're talking about at that particular time. Okay, a value can be represented in lots and lots of ways. For an integer, you could say, well, 5, a whole number, 5. Okay, it's just 5. If you want to get fancy with it, you could say it's 4 plus 1, it's 2 plus 3, it's 6 minus 1, are all ways of representing 5. But most people are going to say, well, 5 is kind of the simplest way of expressing it. For fractions, there's a lot of ways of representing them. For example, 2/4 and 1/2 represent both the same quantity. To see that, let's take 1 whole, and then we're going to divide it both into 2/4 and into 1/2, and consider 1/2. So in the first case, we have 1 whole divided into halves, and we're going to shade 1 out of those halves. In the second case, we have 1 whole divided into 4 parts, and we're going to shade 2 of them. Okay, and both of those are representing the same value. There's a joke that goes with this, actually. A guy goes into a restaurant, orders a pizza, and the cook says, okay, do you want your pizza cut into 6 pieces or 8 pieces? And the guy says, okay, we better cut it into 8 pieces because I'm pretty hungry. Okay. The reason why that's funny is that it's the same amount of pizza either way. And so cutting it into more pieces doesn't give more pizza. In this case, we have half of 1 whole either way, regardless of whether you have it as 1 piece or 2 pieces. Okay. In working with fractions, you always have to have whole cut into parts of equal size. Okay, if you had a cake, I guess I like cakes today. If you had a cake and you were going to cut it into 4 pieces, 1, 2, 3, 4 pieces. There's 1, 2, 3, 4 pieces of cake. Okay, so would you like a piece of cake? Okay, I ate 1 piece of cake. Did I eat a lot of cake? Well, you don't know which piece I had. Maybe I had this little one right here, in which case that's not that much cake. On the other hand, if you had this big kind of irregularly shaped piece of cake, then you had a lot of. If you have your wholes cut into parts of varying sizes, then it's really hard to answer questions about it. So for all of our work with fractions, you'll be able to assume that wholes are cut into parts of equal size. Okay, another important aspect of working with fractions is you need to know what your whole is. The next example will illustrate that. Okay, suppose that Jen cut her pie. We switched from cakes to pies. Jen cut her pie into 6 pieces. She ate 2 and then put the rest in the refrigerator. Beth came home and ate half. How much is left? So for this question, let's try drawing it out. So there's this pie. We're going to cut it into 6 pieces. That's kind of a bad looking pie, but that's okay for now. So there's 2 eaten. Okay, Jen ate these. Okay, so there are 4 pieces left. Okay, Beth came home and ate half. This half right here, is that half of the original pie, which would be 3 slices, or is it half of what was left, which would be 4 slices? Okay, when we say half here, we have to be clear. Are we saying half of the pie, which would be 3 slices, or half of what's left, which would be 4 slices? So you have to be clear on what your whole is. Okay, so these are some of the things that can make working with fractions maybe a little bit tricky, or at least something that you do have to watch out for. All right, in the next part, we're going to be looking at making some sketches to represent fractional values. So in the first case, it says here, write the fraction to represent the shaded part of the figure. So to write a fraction, you need to know 2 things. You need to know how many parts the whole is divided into, and then how many parts we're talking about. So here, the 1 whole is the big rectangle. 1, 2, 3, 4, 5, 6, 7 parts all together. And then out of those 7 parts, it looks like 4 are shaded. So this fraction would be 4/7. Okay, next up, we want to write a fraction to represent the shaded part of this diagram. Okay, so here we're told that this is 10 equal parts. Out of the 10 equal parts, 3 are shaded. So this is 3/10. Okay. One thing you want to be careful with in working with problems like this, by the way, is to make sure that you're counting the spaces between the lines. Taking a look at this 3 shaded parts here. The first piece is this one, the second piece is this one, and the third piece is this one. There are 3 shaded parts. You'll get the wrong answer if you count lines. There's 4 lines right there. Okay? There's 4 lines and 3 shaded pieces. Don't count the lines, count the spaces between the lines. Okay, in the next part, we want to draw sketches to represent these fractions. You can use circles. A lot of times people like pie pictures. If you're good at drawing circles, you could do that, or rectangles. Okay, so it doesn't matter. Just at this point, pause the video, see about drawing some of these sketches, restart the video, and then see what you. All right, so here are some of the sketches I drew. Your sketches can and probably will look different than mine, and that's okay. For the first one, I drew a rectangle. I cut it into 4 parts, and out of those 4 parts, 3 are shaded, representing 3/4. In the second case, I cut a rectangle into 6 parts and shaded 1. Notice that the one that you shaded doesn't have to be especially at the top or bottom. It doesn't matter the placement. Okay, in our third example for 5/8, I drew 8 dots. Out of the 8 dots, I made 5 of them blue. So there's 5/8 of the dots are blue. And then in the last one for 5/6, I made a line segment that is 6 units long, and I made another one that is 5 out of those 6 units long. So that represents 5/6. Okay, some words next. We want to talk about proper versus improper fractions and then also mixed numbers. A proper fraction is a fraction whose numerator is less than its denominator, like all the examples we've seen so far. 5/8, 1/3, 11/16 are all examples of proper fractions. An improper fraction is a fraction whose numerator is greater than or equal to its denominator. Okay, so as an example, the fraction 10/4, which is equivalent to 2 2/4, and we'll talk about why this equivalence is true soon enough. But for now, this is an example of an improper fraction. In this case, 1 whole is one of these bigger triangles, and each of those is divided into 4 parts. So this visual is representing 1, 2 wholes, and additionally 2 out of 4 shaded parts. So 2 2/4. If you just think of it in terms of fourths and count up the little triangles, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those little fourths. Thinking of the problem in terms of fourths, we have 10/4. That's an improper fraction. The 2 2/4, which probably should be simplified to 2 1/2, that is an example of a mixed number. What makes it a mixed number is the fact that we have a value that is partly a whole number, that's the 2, and then partly a fraction, the 1/2. Okay, improper fractions are found whenever we have more than 1 whole of something. Okay, so as examples, let's take and write this quantity as an improper fraction. So it looks like 1 whole is one of these green bars that is divided into 3 parts. So to me, the problem is about thirds. So how many thirds are there? 3, reading across first, there's 3, 6, 9, 12, 13, 14, 14 thirds. Okay, this problem is 14, or value is 14 thirds. A mixed number contains a whole number and a proper fraction. So here, if 1 whole is one of those bars with 3 parts, then this has 1, 2, 3, 4 whole pieces and 2/3 of a 5th one. So it's 4 2/3. 4 2/3 is the same as 14 thirds. Okay, examples. So here we want to represent the shaded part of each figure group as both an improper fraction and a mixed number. So let me do the first one. So for number 10, let's go with the improper fraction first. Okay, so here it looks like one whole would be one of these circles. Each one is divided into 3 parts, so it looks like this problem is about thirds. And how many thirds are there? I see 1, 2, 3, 4, 5, 6, 7, 8 of those thirds. So this value represents 8 thirds. Okay, as a mixed number, well, each whole was divided into 3 parts, so each one of these circles represents one whole. So then we have 1, 2 full whole units, and then 2 thirds of a third one. So improper is 8 thirds, and then mixed is 2 and 2 thirds. Okay, so you try number 11, pause the video, try to write down the improper and proper, improper and mixed versions of this value, and then restart the video and see how you did. All right, so here one whole is divided into 4 parts, and so this problem is about fourths. So it's about fourths. The visual has 1, 2, 3, 4, 5 of those fourths in it. As a mixed number, we have one whole unit and then 1/4 of a second whole. So 5/4 and 1 1/4. Okay, so why both? Why do we have both improper fractions and mixed numbers? Neither one is especially better than the other. It's just that in different areas, it's traditional to use one or the other. In math and sciences, typically it's use either improper fractions or decimals. In the trades like construction, plumbing, cooking, sewing, things of that sort, you're more likely to see mixed numbers and decimals. Okay, so both have value, as it were. Okay, so fractions found using measuring. Okay, so here we want to measure the yellow bar. So here, this is in inches. We have 1 inch here, the yellow bar, it looks like it ends at 3/8. So this is going to be 3/8, 3/8 of an inch. Okay, so make sure that you're okay with reading a ruler. Notice that on the ruler, it's divided in based on powers of 2. We have 1 inch. That 1 inch is divided into halves, and in fourths, then eighths. The next division down will be 16ths, then 32nds, and so on. So it goes by powers of 2. All right, so as another example, we'd like to know how long is this red bar. It is starting at 0, of course. We're ending at 6, and that looks like a little more than a half. It looks like one of those long little bars. Sorry, I don't know well you can see that. It looks like it ends on that little short bar right after the half. I know you were thinking it was 6.5, but it's a little bit past that. So we've got to figure out what that mark represents. So this is the half mark. And then the next length down is going to be quarters. So these are the quarters. And so this is going to be 3/4. So the next division down is eighths. And so the one that I've marked in green is going to be 16ths. Okay, so 8 is going 8/16 will be 1/2. And so this is 6 9/16. If you're not comfortable or really familiar with doing that, you might want to get out a ruler and practice measuring some things and writing down their lengths. Okay, we can visualize fractions by representing them on the number line. We're used to using the number line to represent whole numbers and negative numbers. If we consider all the spaces between those values, we get the fraction. So 3/5, we're going to take the length from 0 to 1, divide it into 5 parts because this value is in fifths, and then 3 of those fifths will be on the left, 2/5 will be on the right. So this dot is positioned right here at the 3/5 location. Okay, so now just for practice, we're going to graph the number 3/4 on the number line. So I'm making a number line that extends from 0 to 2. And then I want 3/4, so I'm going to divide the whole thing into fourths. And so we want 3/4. So starting at 0, there's 1, 2, 3/4. Okay, so we've graphed 3/4 on the number line. Okay, try to graph 8/3 on the number line. So once again, you may want to pause the video and see if you can do this and then see what you get. Okay, so this problem is in thirds, so I'll take each whole and divide it into thirds. And we want 8 of those thirds. So I'll count. We'll have 1, 2, 3, 4, 5, 6, 7, 8 thirds. This time I'm using a dot to represent 8 thirds. For the 3/4, I used a bar. Either way is okay. They both represent the value that we wish to represent. You can use a dot, you can use a bar. Okay, some properties of 0 and 1. Okay, so just maybe review a few. If not, that's okay. If it's review, it's also okay. It's good to refresh our memory on things. Okay, so we studied division in working with whole numbers. Division, of course, is really closely related to fraction. So we want to review these connections. So n divided by n is equal to 1. Again, here thinking in terms of fractions. If you had a whole cake divided into n pieces and you have all n of those pieces, you have one whole cake. If you have 0 divided by n, where n is not 0, then that will be 0. If you have your cake divided into n parts and you have 0 of them, you have 0 cake. Okay. N divided by 1 is equal to n. If you have cake divided into one piece, that is a whole cake, and you have n of them, then you have n cakes. This last one is a little tricky for people. Any number that is not 0 divided by 0 is undefined. Okay, it's not 0. Any number divided by 0 is undefined. How to think about that? There's a variety of ways of thinking about it. One way is you could just remember it, memorize it. Another way is to think about the connection to division. So let's do that real quick. So 12 is equal to 3 times 4. And so that's why 12 divided by 3 is equal to 4. Okay. If we had some number divided by 0, let's say 12 divided by 0 was something, let's call it b, okay? Then following this pattern, if 12 divided by 0 is b, then using the rules of math, 12 would have to be the same as b times 0. But we know from our earlier work that any number times 0 is 0, not 12. So there is no such number b that is going to make this work. Okay, division by 0 is undefined. Okay, a second way to think of this, if that doesn't work for you, is to think like in terms of a story. Suppose that you have 12 cookies and you have 3 kids. And you're going to divide the cookies among the 3 kids. Okay, if you have 12 cookies to split among 3 kids, then how many cookies per kid? It's going to be 12 divided by 3, or 4 cookies per kid. Okay. If you have no cookies divided among the 3 kids, well, each kid is going to get no cookies because you have no cookies to split among them. Okay. How about 12 cookies divided by 0 kids? Okay, let's say you have no kids. If you have 12 cookies and you want to divide them among the non-existent children, okay, how are you going to do that? Okay, well, that's impossible, right? Okay, and so that will be a way to remember that division by 0 is undefined. Okay, so a couple of properties involving 0 and 1. Okay, so in the next set here, we want to do some simplifications. So let's do that. 9 divided by 9 is going to equal 1. Negative 6 divided by negative 6 equals 1. 0 divided by negative 1 is 0, not undefined. 5 divided by 1 is 5. 13 divided by 0 is undefined. Negative 13 divided by 1 is negative 13. Okay, in the next part, we're going to look at how to convert back and forth between mixed numbers and improper fractions. So our first task is to write a mixed number as an improper fraction. There's a couple of steps to this. We'll multiply the denominator of the fraction by the whole number. We'll add the numerator of the fraction to the product from our first step, and we'll write the sum from step 2 as a numerator of the improper fraction over the original denominator. So that is a mouthful. So the best way to see how this goes is by trying it. Okay, so let's say we had 3.5, and we want to change that to an improper fraction. Step 1, multiply the denominator of the fraction, that's 2, by the whole number, 2 times 3, that's 6. Step 2, add the numerator of the fraction to that product. So 3 times 2 is 6, plus 1 is 7. Write the sum from step 2, that's the 7, as the numerator of the improper fraction over the original denominator, which was a 2. Okay, so that's it. More examples. Okay, so here, 1 3/4, we want to write that as an improper fraction. So 4 times 1 is 4, plus 3 is 7, 7/4. 3 5/8, 8 times 3 is 24. 24 plus 5 is 29, all over 8. Notice the denominator is still the same. The first one was in fourths, so we got fourths. The second one was 3 5/8, so we got eighths. 5 and 11/16. Okay, 16 times 5 is 80, plus 11 is 91, 91/16. Okay, we got only a couple more. So 5 and 2/7, 5 times 7 is 35, plus 2 is 37, and that's over 7. 4 and 1/5, 4 times 5 is 20, plus 1, 21/5. Okay, when it's negative, don't let that throw you. If you start thinking negative 24 plus 7, okay, what is that? Don't do that. Just ignore the negative for a minute and then change it as if it were a whole number. So forget the negative for now. 3 times 8 is 24. 24 plus 7 is 31. 31 over 8. And then put the minus sign back on. In other words, convert the fraction piece separately and then just slap on the minus sign when you're done. All right, so we want to see about going the other direction next. So how do you write an improper fraction as a mixed number or as a whole number if it divides evenly? So as before, there are a couple of steps, but basically what it boils down to is dividing. Remember that a fraction really looks like a division, and you can treat it that way. So there's 2 steps. Divide the numerator, divide the denominator into the numerator, or the numerator by the denominator, depending on how you want to phrase it. The whole number part of the mixed number is the quotient. Okay, the fraction part of the mixed number is the remainder divided by the original denominator. So again, that is a mouthful. So we're going to try it some, and then we'll see how it goes. Okay, so 9/5 first. We want to change 9/5. So let's divide 9 by 5. Okay. So 9 divided by 5. 5 goes into 9 one time. 1 times 5 is 5. Subtract to get 4. And then for this, we're not going to put in a dot and a 0 and keep going and stuff because we're not doing decimals here. We're just doing fractions. Okay, so there's no more digits to bring down. So we're going to stop. We're finished. The quotient is the 1. The remainder makes up the numerator, that's 4. And then the original denominator we had, which was fifths, is still our denominator. So 1 4/5 is the same as 9/5. If you liked what we were doing a few minutes ago, that is changing from mixed to improper, you can try that again now. 5 times 1 is 5, plus 4 makes 9. Okay, and then to be sure, if we wanted to draw 1 4/5, let me use 2 whole units. We're going to have a problem involving fifths, so let me divide all these into fifths. If we had 1 whole unit and 4/5, it would look like that. That's 1 4/5. How many fifths is it? There are 9 fifths. 1 in the full block in the top, that gives us 5 of those fifths, and then the partial down below is going to be 4 of those other fifths. Okay, so let's try next. 23 ninths. 23 divided by 9. 9 goes into 23 2 times, making 18, and if you subtract, you'll get 5. Okay, quotient 2, that's the whole number part. The remainder is our numerator, that's 5, and then denominator is still ninths, 2 and 5 ninths. Okay, and again, if you want to change it back, 2 times 9 is 18, 18 plus 5 is 23, 23 ninths. Okay, 13 fourths is next. Let's try 13 fourths. So 13 divided by 4. 4 goes into 13 3 times. That makes 12. Subtract and get 1. So 3 and 1/4. Okay. So last one, our negative one. As when we were going the other direction, we're going to just ignore the minus sign until we're done. Let's convert the 17/12. 17 divided by 12. 12 goes into 17 once. 1 times 12 is 12. Subtract and get 5. That's 1 and 5/12. And now we'll put the minus sign on. Negative 1 and 5/12. Okay, so that's the basics of how to convert back and forth between mixed numbers and improper fractions. There's just one other thing, and then we're done. A couple of things to pay attention to. When you're working with mixed numbers, the fractional part, the proper fraction is off to the right, that needs to be simplified. So if you see something like 3 and 10/15, you don't want to leave it like that. We'll see in a few minutes how to simplify it into 3 2/3. So that fractional part needs to be simplified. Okay, and then also that fractional part needs to be a proper fraction. So you wouldn't want to say, okay, 3 6/5, right? Because 6/5 is itself an improper fraction. So you'd want to rewrite that. So that is 4 1/5. Okay, so that takes us through a lot. We've looked at what the basic idea is for a fraction, some terminology involving numerator, denominator, improper and proper fraction, mixed numbers. We saw how to make some sketches of some fractions. We saw how to think about mixed numbers and how to convert back and forth between mixed and improper fractions. Okay, and that takes us to the end of this first video on fractions. In the next part, we'll look at how to simplify fractions and how we would have done something like change this 10/15 into 2/3. Okay, until then, have a great day.